Hello everyone, thank you. Usually I try to talk about the cool stuff, like TypeScript or GraphQL, but today it will be something slightly different. It will be about how your bundle size can save the climate. Because I think often as developers, we try to think about making our code look pretty. We hopefully try to think about accessibility, making our code accessible to everyone that tries to use it, but we hardly think about the effects of the climate of the code we write. So your bundle size can actually make a difference, and as teaches a bit gave away, maybe even JavaScript isn't the best solution possible, but we'll see. Before I will give you some stats to get you thinking about why your bundle size and the climate can be important for you as a JavaScript developer. So in 2021, the average website was 4 times bigger than 10 years before. And this is actually a stat coming from the Internet Archive or the HTTP Archive, and they collect information about the web and all the websites in general. So 4 times bigger than 10 years ago. And also the internet in total, so this is data centers, this is network, this is mobile phones, computers, everything related to it, is using over 20% of all global energy. So even when we're here today, maybe it's even more because we have a lot of tech people in one room, the internet is using a lot of our energy. So we need to be sure that we use this energy efficiently. And also, something else I keep hearing about it is also, if you're a Harry Potter fan, I am, it's this great scene about Wingardium Leviosa, and you're actually pronouncing it wrong. You often see the same with climate change, so it might not be a hot day today, or maybe it's actually climate change. So try and think about this when you're watching this talk. So a little bit about myself. So my name is Roy, I'm from Amsterdam. I work for a GraphQL company called Stepsin. I write programming books and I speak at conferences. So I'm really glad to see everyone here today. So what has changed? We already saw the average website was 4 times bigger than 10 years ago. So what has actually changed that we're now using so much energy and we have so large websites? So one of it's phone zombies. I don't know if you saw any phone zombies today. I saw some of them, luckily not that much, because people are actually interacting with each other, which is great to see. But phone zombies are actually a thing, but it's also a bit exaggerated, of course, because not everyone is using the phone all the time, but we are using our phone more and more. We spend more time online than we did before, and I think every year it's getting bigger and bigger, this number. And mobile phones have actually become our first screen, so no longer do you need to go to a desktop computer that maybe is at your attic or at your bedroom. Today your mobile phone is in your pocket all day and it's consuming internet and it's browsing to websites. So what else has changed? We're also shopping online. I remember some quotes from people 20 years ago saying maybe the internet will get somewhere. I think today everyone is shopping online and you actually see that over 3/4 of all people buy something online every month. Even our groceries have gone online now, and you can even get a set of bananas at your house within 15 minutes in most countries. So is this actually the problem? Is it us JavaScript developers, or is it maybe all those boxes delivered at your home? So I've been away for a week. Hopefully this won't be by my front door. But there's something else that has changed also, which is the web itself. As we already saw, in 2021, the websites were 4 times bigger than they were 10 years ago. So something has changed there as well. Maybe it's all the content we produce, or maybe it's the websites we create, or maybe it's something that builds our websites. I actually saw some things on Twitter, and I also asked people, what is your JavaScript bundle size? Does anyone here know what their JavaScript bundle size is? I don't see many hands, so people probably won't know. So I asked on Twitter, and some people said it's below 2 megabytes, which I think is hard to do unless you maybe have a portfolio website. Some people thought it was between 2 megabytes and 5 megabytes. But the weirdest part is nobody knows. Sometimes you know how fast your website loads. You maybe know how high your energy bill at home is or what you pay for your mobile cell phone. But you have no idea for the code that you ship, how expensive it is for all the people reading and using your website. So bundle sizes are important. But let's take one step back. Before we actually have a bundle size, so what will happen? You're with your team, you're at home, or maybe you're a solo developer and you're building a website. The actual programming language that you use for this website is maybe as important as the actual code that you ship. If we look at Stack Overflow, we actually see that JavaScript, HTML, CSS are the biggest programming languages out there. And I don't want to get in a discussion if HTML and CSS is actually a programming language. So maybe try and do that with a beer after this talk. And also Python. Python has also been increasing a lot. More and more people are using Python. And it's for a reason, right? Because just as JavaScript, it's an accessible language that's easy to learn, relatively, of course. But most of all, JavaScript is being at the top. It was popular 10 years ago, but now it has even become more popular. I'm not even sure why SQL is listed here, but who cares? And then some people sometimes ask me questions. So yesterday I was walking around, some people asked me, what will you be speaking about? So I was talking about your bundle size and the climate and how you as a programmer can actually make improvements here. And then someone asked me, is a fast language always energy efficient? Does someone think a fast language is energy efficient by default? I don't see many hands, or maybe people don't dare to raise their hands. So we're going to look at a fast language. Is it actually energy efficient? If you had physics, you maybe know that energy is times against the power. And this is in regular physics. So you would have energy, and energy is composed of the time and the power that you put into it. So this is how physics works. If you had some physics at your high school, you maybe know. But not in our world, because we're software developers, programmers, our rules are a bit different. So in our world, maybe energy isn't a consistent of time and power. Maybe it's something else. So let's try and put it in numbers. And actually, scientists did this for me. So I didn't do this myself. I'm not that smart as these Portuguese people that actually created an entire report and research around energy efficiency and programming languages. So they checked how energy, time, and memory, so memory is power in this case, related to the consumption of a website, or actually a programming language. So it can also run server-side or wherever you like to run this code. So they took some languages. You can see the list is quite long. You can even see the functional languages, imperative, object-oriented, and scripting languages. JavaScript is actually in both. So it's also in object-oriented, but also in a scripting language. Is someone using JavaScript for object-oriented stuff? I never tried it, or maybe I should. The last time I wrote a class has been a long time ago. I mostly do functional programming, which JavaScript can do in a way, of course. So they took some programming languages, and then they also threw in some algorithms. And it's quite a long list. It actually comes from a computer language challenge. So people try to make challenges, try to figure out how they can solve certain algorithms in different programming languages. And they took an example, binary trees. Probably everyone knows what a binary tree is because you did them when you applied for a job, right? Who did a binary tree when they interviewed somewhere? No one did? I think these days most companies try to do binary trees. So that's why people probably know them. And they also did something else which spoke to me even more. It's like Pfannkuchen Redux. So Pfannkuchen sounds like pancake in German. And then Redux is something for React, right? And it's also an algorithm. And it's quite a fun algorithm. So you would have a set of numbers. And in this set of numbers, you would take the first number. And then you should flip it and reverse the first n number. So if your first number is a 4, you should flip it. You should flip the first 4 numbers. And you keep doing this until the first number is 1. So this is one of the algorithms they did. So does someone try to dare say how many times they need to flip it? Maybe just shout it, or we can try. Maybe it's 3, is it 4, is it 5, is it 10? 4. Well, maybe you're close. So it's 5 times actually. So you take the first number, you flip it, you reverse it, and you keep doing this. So it's 5 iterations in total, and the final number should be a 1. I actually pasted this 5 over it, but if you look at the one with the 4, you can probably reverse it in your head. So this was one of the algorithms they tried, and then they tried it with different set of numbers, of course. So this sounds easy. It's a Pfannkuchen Redux algorithm. I never heard about it, but it's kind of nice to know. And we did, they also created a table with a total overview of all these different programming languages, so how they would map against energy consumption, the time they took to solve all these different algorithms, and then also the amount of memory they allocated. And this is a normalized list, so megabytes is actually memory. And you can see JavaScript isn't ranking that high. The numbers actually don't say anything because it's normalized, so you don't get any absolute numbers from here. It's also different per algorithm. But you can see in general that C is doing very well, Pascal is doing very good, and I believe the creator of Pascal also created TypeScript, which somehow is doing not so well. So you can see, except for time, TypeScript is in the same areas as JavaScript. You can probably guess why, because you need to compile it to actually run as JavaScript, so it will take you longer. But you can see JavaScript is doing quite bad. So luckily PHP is doing worse, so that's a good thing to see. But something else that compels to me is Rust. So Rust is it's not a new programming language, but it is something I see more and more JavaScript developers get interested in. And as you can see, they're doing quite well on this list, so it might be a nice moment to check it out. So if we go back to our statement, a fast language is often energy efficient. If you look at this list, there is no direct correlation between time and actual energy it needs, because JavaScript is taking only 6 in a normalized list, and then TypeScript is taking, I don't know, let's say 8 times more. But still, the energy they consume is about the same, or not as much difference as within the time consumption. So there is no direct correlation. Also, if you look at different numbers, so a fast language is often energy efficient, is something that's not directly true. But for a website, that's different. So if we get back to the title of this talk, how your bundle size can save the climate, we now know JavaScript might not be the best language to use, but also JavaScript has done great things for me and hopefully for everyone in this audience. So a fast website is often energy efficient. This is something we can actually test also. And for this, we like to look at websites 10 years ago. So maybe you remember 10 years ago you open a website. Does it look any different than it does today? I think if you use the Wayback Machine from the Internet Archive, you can actually see it looks quite different. Facebook looks old, and Psy with Gangnam Style is somehow popular. So this Wayback Machine actually shows you websites back in the past. I recently tried this for one of my first websites actually, and it was still there, which is quite cool because I didn't save the screenshot. So if you're here today, make screenshots of all your websites or use the Internet Archive Wayback Machine. But today websites look very different, and much has changed, except I've found one website that didn't change in 10 years. So this is Hacker News. Do you know which one is the older version? Is left? Or do you think it's right? So people think it's right. It's too small to read probably, but it's 10 years different and the website is still the same. So Hacker News probably didn't update their website. So my statement that websites look different now is not correctly, but still, most websites do look different 10 years later. And nowadays they're also built on popular JavaScript frameworks or libraries. So you have Svelte, you have Angular, hopefully no longer AngularJS, you have React, you have Vue, and also vanilla JavaScript, and probably there are way more things coming up. And these JavaScript frameworks, they can be misused quite easily. And if you go back to the top languages, you can see JavaScript is at the top, and probably most of these people are building with JavaScript frameworks or libraries, and maybe not that much people are building with vanilla JavaScript. So you can imagine that all these applications are also consuming lots of data. Because as I mentioned, except Hacker News, all websites now look way different. There's more data involved, there are more images, higher quality videos. So websites are consuming more data, and they're also bigger than we saw before. If you look at this one from the HTTP archive, you can actually see the median size of a website or the median size of data a website consumes is increasing. And it has been increasing a lot. If you go back, it's almost a flat line in the beginning, like 10 years ago, and now you can see it's way bigger. People saying their JavaScript bundle is below 2 megabytes are probably lying because this is the average website size. So websites should be optimized for usage. That's something that's really important to keep in mind. So when you're making your website usable by your users, don't only think about accessibility, but maybe also about the energy efficiency of your website. Because we developers can do that. You're writing the code with your team or by yourself, so you in the end determine what the product will look like, but also the quality of the code you ship, the bundle size you ship, or how accessible your website is. So let's try and put this in some numbers. I actually found a website that can do this for me. You can actually do it yourself as well. Just try run some load or performance test against your website and we'll figure it out. But there's a website called websitecarbon.com. And it will look at how your website is impacting the planet on different statistics, on data transfers, the energy intensity of your website, also website traffic, which of course is important because you have a large bundle size, but nobody's looking at your website. Maybe remember that side project. But if 100,000 of people are watching your website every month, it gets more and more important how efficient this website is. So in here you can actually just paste your own website and figure out how good or how bad it is for the planet. And something else they will doing is quite cool. They also look at the energy source of the data center. You can actually find out, there are multiple websites for this, what your data center is using in terms of energy. So are they using gray energy or like fossil fuel, or are they actually working with wind and solar energy? So this is public data, you can actually find it online. So let's try it out. I took this website, make frontend shit again.party. It's built by Sarah Vieri, a great speaker. And this website is using multiple JavaScript frameworks at once. So it's using JavaScript, it's using React, it's also using Vue. It uses tons of animated stuff. There's audio on there, and I don't know, just try it out. It feels like you're back in the early 2000s or maybe later, and looking at your first website. Things are moving all across the screen. So you can imagine it's a large website in terms of bundle size. There were little to none optimizations done. You can actually see the bundle size around 10 megabytes. And something else you know is anyone using Safari as their default browser, except on their mobile phone? Some people are. It's quite cool. If you go to the developer tab of Safari, you can actually figure out how bad or how good your website is for the environment. You can find the CPU usage of the website. You can also see it in this list. And they actually have some extensions to look at the carbon footprint as well. But if we insert this in the website, websitecarbon.com, you can actually see that over 1 year with 10K monthly users, this website is using a lot of energy. So it's using over 1,200 kilowatts of energy, which means you could drive 10,000 kilometers with an electric vehicle. And also you would need to plant 28 trees in order to compensate the energy this website needs. So this is something you'll see if you don't do any optimizations and you're using multiple JavaScript frameworks alongside, but maybe even just one on a large website. It is something that can truly impact the climate. And then we have this mother effing website, which is built with just HTML. So this is a simple website doing nothing with just playing this data. And I tried to bleep out all the bad language, but you can see it's a lightweight website. It's only 20 kilobytes to load in the browser because it's just HTML with text. Of course, you'll see some JavaScript because it needs to render in the browser, but it is lightweight. And you can also see the CPU usage is bare to minimum. I don't know if you ever look at the CPU usage of your website. I sometimes try to do it while I'm in a video call. It's crazy. Sometimes it even maxes out over 100. But it can also happen with a website. If you have a large website, a bundle that needs parsing, right directory, and browser, it is something that can be quite energy consuming. And this website is actually good for the climate. There isn't much to see, so probably 10K monthly people is like a stretch. But this website would only need 3 kilowatt hours of energy, which isn't that much. It's probably the same as a light bulb in your house. And you only need to plant 1 tree to compensate the energy. So even if you don't have a garden but a balcony, you can maybe plant some small tree or flower there to actually compensate for the energy usage of this website. So it's kind of mind-blowing for me. The difference is huge, of course, and these are both, well, probably a website you won't build yourself, but it's something to think about. If you have a bundle size that goes towards the 10 megabyte threshold, you can see the energy impact it has, but only 10K monthly visitors. But let's imagine this is like a large e-commerce platform, or it's maybe a telephone company that's selling bundles every day. So if you put this alongside, you can see the difference. So to me, it really shook my mind. If I open a website, I never actually realized that opening this website will do multiple things. So my computer needs energy to render this website in my browser, which depending on the bundle size can be quite a lot. And then also the API calls, or actually the data transfers coming from a data center that is also using energy to get this data to the user. So there are multiple points at which you use a lot of energy to show a website to a user. And the difference is quite huge. So what can you do to make this better? We already saw JavaScript might not be the best language to actually build your project in. But then again, JavaScript runs in the browser, and well, other languages don't, or at least most languages don't. You always need to compile them to JavaScript. So we're kind of stuck to using JavaScript, at least for our front end. For your back end, you're pretty open. If you have a server that can run anything, you should be fine. So what can you do? There are multiple things you can do, and I'm not a performance expert, but something you can do is code splitting, of course. If you work with popular JavaScript frameworks, there are code splitting functionalities in there. So you can split your code, maybe even on component level or by page level. And this is something it is quite easy to do, and something that maybe even most front-end frameworks should do for you. So code splitting is a huge thing. Actually, in the ECMAScript specification, you can find a way to also do code splitting by importing NPM libraries, and not importing them every page, but only importing them when you're using them. So these are important things to think about, because maybe whenever someone is watching the homepage of your website, they don't really care what is behind on a different screen. I actually saw products where people are loading the admin dashboard whenever you're watching the homepage, while that user might be a regular user that won't be using your single page application that runs on the dashboard. So code splitting is a large one. Also caching. Caching is very important. I actually saw websites not using cache. So sometimes the browser helps you caching, which is great. You can actually set the threshold. So how long should the browser cache your website, or should they cache your resources? These are all things you can put in the browser. You can actually help the browser with it as well. Compressing is another important one. If you have a website, you can even try and gzip it and send a gzip to the browser, which will be even faster. It might be using a bit more CPU, but really, depending on the use case, it can be that this is actually good for you. And then in gzip, there are multiple things, or multiple ways to compress. So also have a look here. If you experience you have a large bundle size, a quick and easy fix is just turn on gzip compression. And then a CDN. CDNs is something I really like. I always use this example of a luxury car brand, and I won't call the name because they probably don't like it, but they actually started loading a 30 megabyte video as soon as you opened the homepage, and it didn't even autoplay. So you open this website on your mobile phone, maybe you're in a bus or in a tram or in a train or just sitting here at a conference and you're trying to buy a luxury car. I hope I could afford it, but still, you're getting 40 megabytes of data in there, which is fine if you're in Europe and you have a shared data plan, but let's say you're somewhere else, you're maybe visiting a foreign country. So one of the speakers told me that how expensive data was in Africa. If you try to load this website in Africa, it's crazy how much money it will cost you. So CDNs are important because they will help you compress or actually resize the data that you're loading while also adding caching. And then static websites. Static website is a big thing today. Maybe people still use the term Jamstack. I think most of us have a Jamstack website, while the term itself maybe isn't that alive anymore. But static websites are becoming more important. You already saw it on the example. A small website takes way less data to load, and also because you're not compressing too much JavaScript on the browser, it's also more cheaper for the user actually loading the website. So static websites are important. In most modern JavaScript frameworks, you even have ways to incrementally, statically build your website, meaning if someone is watching your homepage and they're hovering over a product, you can actually render the static website on the server and then send it to the front end in case someone actually clicks that button. Which of course are also things you should optimize because you don't want this running all the time if someone is just using a screen reader and going to all the pages. But there are multiple things you can do, and as I said, I'm not a performance expert, but these things don't have to be complicated. If you're not working at Facebook or you're not working at Amazon, it probably doesn't really matter too much how you implement these things, but how you actually start implementing them is the first step. So try and keep these things in mind whenever building your website with JavaScript. And also where your story application matters. I already told you some data centers are using green energy, some aren't. Probably no one really looked at where the data is stored or and how they store it, and if they're using green energy or gray energy, as sometimes it is called. So gray energy could be green energy, it could be fossil energy, you don't really know. And actually most data centers operate on gray energy. So you have no idea where the energy is coming from. It might be green, it might not be green. It could also be Tesla just selling all their green emission certificates to someone that is burning coal to render your website. So where your story application actually matters. And as I saw before, 21% of all the global energy usage is for the internet. So everything we do on a daily basis is using tons of energy. And it's mostly through data centers. So picking your next data center can also be important. So if you're looking at cloud providers, Google it please and check if they are using green energy to fuel the data center. And there's much more data centers can actually do. They can actually reuse the heat they produce because servers produce a lot of heat. I don't know if you remember those old desktop computers. They get really warm and noisy, and servers are basically making the same heat and noise as these desktop computers. So this extra heat can be used to actually heat your home, or maybe even a museum, or maybe a school nearby. So data centers can do much more than just producing energy. I come from the Netherlands. In the Netherlands we have a big problem with data centers, because data centers are eating away all our green energy, meaning green energy won't go to homes, but it will go to data centers instead. So we need to make sure that these data centers are actually using the excess heat they produce to heat those homes in return. So it's important where you store your data, but it's also important how you create your bundle size. Because green energy hopefully is also becoming the norm. Maybe at your home, if you have the luxury of being able to have your own green energy resources, like a solar panel or like a heat pump, but maybe also your energy provider. If you can choose them, try and find one that uses green energy, because in the long run it will help us. And then the final question, I guess, is should I stop using JavaScript? So this is a question people start asking me. I think it's good to be curious and to experiment with other languages. I showed you which languages are energy efficient. I can also post it on Twitter if you want. You can find my handle on the right bottom, and then you can make a choice. Maybe you want to learn Rust, maybe you want to go back to maybe the early days. If you went to university, you probably learned C or C++ there. Those languages are harder to use, but they are more energy efficient. So should I stop using JavaScript? I think you shouldn't. I mean, we're here with a great group of people, all loving JavaScript or maybe TypeScript, and it brought us quite far. So you shouldn't stop using JavaScript, but you should be aware of how you actually implement your JavaScript, how you create your bundle size, and where you store your energy. So with that, I'd like to conclude. So thank you all for listening. And if you have any questions, I'll be around for the rest of the evening. So over a beer or something else to drink, I'll be happy to brainstorm about your ideas to make the world a bit greener. Thank you.